All right, what we're going to do in this segment of the lesson is we're going to understand leftward, well, I guess from your perspective this is left, so leftward and rightward translations of an exponential graph, okay? So basically the idea is this. You've already learned how to identify the base. You know, if we have an exponential function, you've already learned how to identify the base based on this distance, and you've learned to identify whether the graph is in its normal position or whether it's reflected vertically or whether it's reflected backwards or horizontally across the y-axis or across the x-axis. Okay, so we've learned our reflections and we've learned how to identify the base. We also have another segment which you've probably already watched where we identified how to understand vertical translations of the exponential graph. In this lesson, we are going to ignore the vertical translations. Okay, we're only going to focus on horizontal translations of the exponential graph. So you could actually watch this video first and then the one with vertical translations. And then what we'll do in the next segment is we're going to put together the vertical translations and the horizontal translations and do both of them at the same time. But in this video, it's just horizontal translations, left shifts and right shifts of the exponential graph. Okay? All right, so let's go ahead and look at an exponential function. Now you should be able to, based on what you learned in the previous set of lessons, you should be able to identify the equation of this function. Okay? If we go ahead and draw in the horizontal asymptote. Now in this lesson, the horizontal asymptote is not very important at all because we're going to do a left and right shift. Left and right shift will not affect the asymptote at all. It'll still stay right on the x-axis when we shift left or shift right. Now you've learned that once we have the asymptote, we can plot this point right here, which is it's the point 0, 1. That's if it's above the x-axis. If it was reflected below, it would go through the point 0 and negative 1. Okay? And now you've also learned that if we go 1 unit over from this point, from right here, we can go the distance from the asymptote up to the curve, and that will tell us the base of this exponential function. The distance from here to here is 2, and therefore this exponential function is equal to, well, it has a base of 2, but we also have to know whether there are any negatives in it, right? We learned about reflections. Well, this graph is in the normal position. It is above the asymptote, which makes it positive, and it's flat to the left and steep to the right, which means that it is not backwards. It is neither upside down, nor is it backwards. Therefore, there are no negatives on this one. It's just 2 to the x power, okay? All right, so what we're going to do now is we're going to see what happens when we translate this same curve to the left or to the right, okay? And what I need to do is I need to tell you what to look for to determine that translation, and I also have to show you where to write it on the equation. All right, so you can see here that what I've done is I have shifted the curve from its original position, which was going through this point, and it had a base of 2. It would have also gone through this point right here, okay? And so it looked like this previously, okay? But now it has shifted from this position, it has shifted to the right. And we're going to try and identify how far to the right and how we can indicate on the equation what a rightward shift, how a rightward shift is indicated, okay? All right, so here's what we're going to do. First thing we always do on any of these problems when we're trying to identify the graph is we draw in the asymptote. So here's the flat part right here. That's where the asymptote is. We're going to draw in the asymptote. Even though with a horizontal shift, we're not going to have a shift of the asymptote, we're still going to draw it in. See, the asymptote is going to help us in identifying the base, but it also helps us identify what I call the point, okay? The most important point, which previously was the point 0, 1. But you can see now that this graph does not pass through 0, 1. The point 0, 1 has moved over to the right. The way you identify this point, and this point on the curve is what is going to tell you the horizontal shift, the leftward or the rightward shift, okay? So here's what we're going to do. To identify that very important point, you're going to go to the asymptote and you want to go either 1 unit up or 1 unit down from the asymptote. To know whether you should go up or down is just determined by whether the curve is above the asymptote or below the asymptote. This curve is above the asymptote. Therefore, from the asymptote, we're going to go 1 unit up, and then along this horizontal line, we're going to go over to wherever the curve is, and boom, there's the curve 1 unit above the asymptote, okay? Now, this is going to tell us how far the curve shifted over. Now, obviously, we still have to identify the base. So from this point, we're going to move over 1 unit. We're either going to move over here or we're going to move over here. Well, how do you know which direction to move? Should I move over to the right or over to the left? Well, it depends on which direction the curve is turning. If it's going up to the right, you're going to go to the right. If it's going up to the left, you're going to go over to the left. Ultimately, when you move 1 point over from 1 unit over from this point, you want to be between the asymptote and the curve. That's why we're going to go over here. When we go 1 unit over from this point, okay, that's that vertical line right there. We want to go down to the asymptote, and then we want to go up to the curve, and that whatever that distance is, that is the base of the exponential function. As you can see, it's 1, 2. This distance is 2. Therefore, this exponential function has a base of 2. Now, we already knew that because I told you I was taking the same curve and shifting it over. But it doesn't hurt to see it again, at least to me. Repetition of good knowledge reinforces good knowledge. All right, so now that we have the base, we know that this is going to be f of x is equal to. Also, it's not reflected below the asymptote. Therefore, it's going to be positive. So we're just going to put a 2 here. It's also not backwards. So we would put up here just an x, right? All right, so here's how we know. Once we know the horizontal shift, here's what we're going to say. The horizontal shift is indicated in the exponent with the x. In the exponent with the x. Okay? And what I do is I put it in parentheses. So up here in the exponent, we're going to put some parentheses, and it's going to start with an x. And now what we're going to put here is we're either going to put a plus a number or minus a number. Now here's what you have to understand. The horizontal shift is going to have an opposite sign. An opposite sign of the shift. So, if we have a positive shift to the right, it's going to have a minus instead of a plus. If we have a leftward shift, okay, if we have a negative shift to the left, it's going to have a plus instead. Now, you may remember that concept when we did polynomial graphing, right? We said that, if we had a factor, if we had f of x is equal to x minus 3 times x minus 7 times x minus 9, the intercepts, right, would be on the positive side, right? And that's because positive 3 minus 3 is 0. So our intercepts would be at 3, and then at 7, and then at 9, right? Because x minus 3 indicates a positive x-intercept, x minus 7 indicates a positive x-intercept. But let's say this said x plus 9 instead. Well, this would indicate an x-intercept at negative 9 over here. So I hope you're already accustomed to the idea that when you have a binomial with an x, an x minus indicates a positive point and an x plus indicates a negative point. Okay. Well, it's the same thing here with exponentials. So before we write something in here, now we need to know how do we identify how much of a shift it is. Okay. Well, see this point right here. Your shift is going to be however far this new point is from the point 0, 1, okay, or 0, negative 1, okay. So how far, or let's say how far it is from the y-axis. Okay, so the horizontal shift is determined by how far the point, I told you I call it the point, always have to identify the point on the curve, how far the point is from the y-axis. And we're talking about a horizontal distance here, okay? So how far is this point from here? Well, it's 1, 2, 3, 4, 5. 5 units away, that means that this is a 5-unit rightward shift. Because it's a rightward shift, we're going to say negative, okay? And therefore, this is going to be x minus 5, okay? And so, the equation of this curve that we're looking at is f of x is equal to 2 to the power of x minus 5. Now, that x minus 5 has to be in parentheses, okay? Now, when you're taking the quiz online, the way that you would write this would look like this. You would write f of x is equal to, you would put a 2, then an exponent symbol, then a parenthesis, then an x minus 5, and that's how you would write it in. 2 to the power of x minus 5, okay? All right, let's do a couple more examples. All right, so let's try this one. We have, it's below the x-axis, so obviously we're going to have a reflection here. It's upside down, so that's going to indicate a negative in the equation somewhere. Now our first step is always going to be to draw in the horizontal asymptote. So here's the flat part, so we're going to draw in the horizontal asymptote right here along. It's still on the x-axis, no vertical shift here. Okay. Now what we're going to do is we are going to plot the point, right? We are going to go 1 unit, either 1 unit up or 1 unit down. Okay, so from over here we'll go 1 unit up. Well, we don't want to do that. We want to go 1 unit down because the curve is below the asymptote, right? All right, so we're going to go 1 unit down, and then we're going to go horizontally along this line until we hit the curve, which is right here, and that makes this the point. Okay, so we've got the point right there. Now, to find the base of this exponential function, we need to go 1 unit over, and we're going to go in this direction because in this direction, it's this point. This is now between the asymptote and the curve. So this is where we want to be. Then vertically, we're going to go up to the horizontal asymptote. We're going to measure from here along this vertical line, which is 1 unit over from the point, till we get to the curve, which is right here. Now, the distance from the asymptote to the curve is more than 2 but less than 3, but it's closer to 3. That's an indicator that the distance is e, okay? So now we have the base. We also know f of x. We also know that this is upside down, right? It's below. That means it's going to be negative of e. And now we need to know, is the exponent going to be negative? Well, no, because it's not backwards. We're flat to the left. We're steep to the right. Therefore, we're not going to put a negative on the exponent, okay? What we do need to know is, what is the exponent going to be? We know it's going to have an x in it. It's going to be either x plus something or x minus something. And it depends on the horizontal shift. Well, this says the horizontal shift is determined by how far the point, which is right here, how far is the point from the y-axis? Well, here's the y-axis. All right, well, how far over is this from here? 1, 2, 3. So it's a distance of 3. But it's back 3, right? So it's like this is at negative 3. In fact, all you have to do really is plot the point here, which is negative 3, comma, negative 1. You can ignore the negative 1. All you care about is the x-coordinate. Whatever that x-coordinate is, that is the horizontal shift of the curve. But remember, we are going to switch the sign. It says have an opposite sign of the shift. So instead of putting minus 3, we're going to put plus 3. And here's why. You should be able to plug this x-coordinate, negative 3, into x and get 0. Negative 3 plus 3 equals 0, and then we would be back over here to the normal. Okay? So the equation of this curve, of this graph, of this exponential function is f of x is equal to negative e to the power of x plus 3, okay? I think we should do just a couple more examples to get a little more practice. All right, so here's another curve. It's obviously been shifted either left or right. It's not going through this point, 0, 1. Do you want to try and pause the video and see if you can figure this one out on your own? All right, so the first thing I'm going to do to figure this out is I'm going to draw in the horizontal asymptote. And I could get really persnickety here and use a straight edge. If you want to use a ruler to do this, some people, they really want that line, that asymptote drawn in nice and straight. So if that's you, then by all means, use a ruler. That's fine with me, okay? It's your work. All right, there's my horizontal asymptote. Now I know I need to identify where is the point, right? So I either have to go 1 unit up from the asymptote or 1 unit down. This curve is above the x-axis, or it's above the asymptote. So I'm going to go 1 unit up. Then along this horizontal line, I'm going to move over until I hit the curve. Boom! There's the curve. That's the point. So I'm going to put a dot right there. That is 1 unit up from the asymptote. Now what I'm going to do is I want to know what is the base of this exponential function. So I'm going to go 1 unit over. I'm either going to go to the right. Nope, because I got to be between the curve and the asymptote. I'm going to go to the left. Over here, I'm between the asymptote and the curve. Therefore, this is where I want to be. 1 unit over and along the vertical line. That's 1 unit over, okay? I want to go down to the asymptote, so starting right here, and I want to measure the distance from here. I don't have to draw, I just have to measure the distance. I'm drawing so I can show you what I'm doing in my head. Boom, there's the distance right there. All right, so how far is that? That's 1, 2, 3, 4, 5, 6. So this exponential function has a base of 6. Now I can also tell you that it does not have a negative in front of it because this graph is above the asymptote. So it's not upside down, okay? So we know that we're going to have f of x is equal to 6 to some power. Now, is that exponent going to have a negative in front of it? Well, this curve, instead of being flat to the left and steep to the right, is steep to the left and flat to the right. Therefore, this curve is backwards. It's been reflected backwards, okay, or reflected horizontally. Therefore, we know that there's going to be a negative on the exponent, okay? Now, this is critical. Remember I said a couple minutes ago that you have to put the exponent in parentheses? It is even more critical that you put it in parentheses when you have a negative here, because if you don't put it in parentheses, then you have to remember to distribute the negative. So we are only doing parentheses here, okay? You put your negative, then you put your parentheses. And we know that there's going to be an x with either a plus or a minus and a number, depending on the horizontal shift, right? All right, well, let's find out what the horizontal shift is. Normally, here's the y-axis, right? And we know that our shift is however far that point is from the y-axis. So let's count. 1, 2, 3, 4, 5. This point is 5 units over from the y-axis, but it's in the negative direction, right? So we have a -5 shift. Another way of doing that is to plot this point. Well, this point is at -1, -2, -3, -4, -5, and 1. -5 and 1. Well, we don't care about the 1. We only care about the -5. That's what matters. So this is a -5 shift on this curve. But we don't put -5. We reverse the sign and we put +5, and this is our function. It is going to be f of x is equal to 6 to the power of the negative of the quantity x plus 5. Okay? Let's do one more example, and then in the next segment we'll put together the vertical and the horizontal shift in one thing. All right, here's our last example. If you want to, pause the video and see if you can figure this one out on your own. All right, so first thing I'm going to do here to try and figure out the equation of this graph is I'm going to draw in my horizontal asymptote. Okay, so drawing my dashed line right along here. See, I always start with the flat part of the curve. Wherever the curve is flat, I just extend that flatness out along that horizontal line. That gives me my horizontal asymptote, okay? Now I need to identify the point, right? So I'm either going to go 1 unit up or 1 unit down. Well, this curve is below the asymptote, so I'm going to go down from the asymptote, and then I'm going to go horizontally over to where the curve is, and boom, There is the point. All right. Now I need to know the base of the exponential function. So from that point, I'm going to go 1 unit over, which is this direction, because I want to be between the asymptote and the curve, right? So I'm going to go this direction. And vertically, I want to go to start at where the asymptote is, 1 unit over from this point, and then 1 unit to where the asymptote is. From here, I'm going to measure the distance all the way down to where the curve is, which is right there. We've got a distance of 1, 2, 3. So this has a base of 3. Okay? All right. So I'm going to go f of x is equal to, now, this curve is below the x-axis. Excuse me, I keep saying x-axis. I mean to say asymptote, because when we put these together, we're going to have vertical shifts. This curve is below the asymptote, therefore it's a vertical reflection. It's upside down. So we're going to put a negative in front and then the 3, okay? Also, this curve is flat to the right and steep to the left, therefore it's backwards, because normally we're flat to the left and steep to the right. So this one is backwards, therefore there's going to be a negative on the exponent, and then our parentheses, so we'll have an x and then either plus or minus some number. To find out the horizontal shift, we're going to count from the point over to the y-axis. That's a 1, 2, 3, 4 shift. Now it's shifting from the y-axis in a positive direction. So we have a positive 4 shift, but we have to reverse the sign. So instead of putting plus 4, we're going to put minus 4. And therefore, the equation of this function is f of x is equal to negative 3 to the power of negative quantity x minus 4. Okay? Now, how would I write this in my answer box on the quiz? Well, on the quiz, what I would want you to do is I would want you to write the negative, then the 3, now the exponent symbol, then the negative, then a parenthesis, then an x minus 4, and then close the parenthesis. And this is how you would write this answer on the quiz, okay? All right, so that is a horizontal translation of an exponential graph. Now what we're going to do is, in the next segment, is we're going to put together the vertical translation and the horizontal translation into the same graph, and I'm going to show you how to identify the full equation of an exponential graph with a vertical and horizontal translation.